switching to onboard power. Let's watch.
Lagage du mât KZM. À tous de DDO, attention pour les débuts de la séquence d'allumage du lanceur. Top, à 0-20 secondes. Lagage du mât VKM, allumage triétage. À tous de DDO, attention pour les décomptes finales. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Top, décollage IVS 22. La propulsion est nominale.
We are off. The next 4 satellites in the O3B constellation have started their journey. Our cameras following the launcher there as she lifted off from the pad here in the Amazon rainforest. He's telling us that everything is going according to plan. Those 4 boosters are doing all the work right now. They're hauling us away from the gravity of our planet. They burn for a couple of minutes, but that's enough to get us away from the pull of Earth.
La propulsion est nominale.
And their propulsion is normal. Nominal means normal. Bottom left-hand side of the screen, 37 kilometers above the Earth right now and climbing. This is the scheduled moment for the boosters to be jettisoned. And that's what it looks like up there. Cameras on a previous launch. See how they twist and turn. That's all planned.
Séparation des boosters.
And that's been confirmed. We have separated our boosters. And I can hear the sound of the Soyuz here now over the Mission Control Center, which is about 20 kilometers from the pad. It takes a while for the sound to get to us. Trajectory on the top right-hand side, the planned trajectory is the yellow curve, and the cross is the actual position of the launch vehicle. You can see that we're climbing. Our distance in the middle of the bottom of the screen is the distance from the pad if you were to draw a straight line from the pad to the position where the launcher is. And then our speed on the bottom right. Speed on the bottom right is our speed per second, kilometers per second. We're traveling at 2.19 kilometers per second. As we turn around, we're getting a good shot here of the fairing. That's the top of the launch vehicle, and inside there are our satellites. It's protecting us from the rigors of the launch, various things, the sound at liftoff, the acoustic vibrations at liftoff. Don't think you need me to tell you how loud that is.
Le lanceur est stable.
He's telling us the launch vehicle is stable. And also, of course, friction, because if you look at the bottom right-hand side of the left-hand side of the screen, we are now 120 kilometers above Earth. Until now, we've been flying through the dense part of the atmosphere, but we no longer have friction because we are in space. So we can jettison our fairing.
Séparation de la coiffe.
And that's now been confirmed. We have jettisoned the fairing, and we can see our satellites for the first time. The 4 O3B satellites at the front attached to their special dispenser. And in the middle, can you see a gap between the third stage and the second stage? Well, that's there on purpose with the lattice area. That's because Soyuz uses what's called a hot stage technique. It switches on the engine of the third stage while the second stage is still burning, and that allows the evacuation. So,
Séparation bloc A.
And we have confirmation there that we've now separated the second stage, the block A, and we have jettisoned the rear section. So we are now burning the third stage, and our flight path, you can see it there. We're traveling along the equator, so we've lifted off from the pad. The Galileo is the tracking station here at the Guiana Space Center. And the next one to pick us up will be the Natal tracking station. These computer-generated images are a simulation of what the experts have planned. And it's what they've calculated is happening to the launcher and the satellites.
La propulsion bloc I est nominal.
The propulsion's nominal, confirmations. But we're seeing key moments happening at the scheduled time. Telemetry is also known as telematics. Telemetry, of course, being the name for the process of sending the signal to the tracking stations. We use telemetry. And it's a technology which allows measurements to be taken from far away. It actually comes from the Greek, tele, which means remote, like television or telemedicine, medicine from a distance, and metron meaning measure, so measurement from a distance. It's used in a lot of industries, oil and gas, for example, medicine, healthcare, mining. So this is the scheduled separation now of the third stage, and that's what it looks like up there.
Séparation frégate.
And we have that confirmed by the range operations manager. We've separated the third stage, and we are getting close now to the next phase of the journey where the upper stage will take the wheel. It's preparing to switch its engine on. This is called the pre-burn phase, giving a quick burst of acceleration. You can't really see it, but it's pushing the fluids back into the tanks. And that's to make sure that there is enough propellant to ignite the engine properly. It's a bit like when you press the accelerator in the car.
Now I would like to take the opportunity to thank Thales Alenia Space for their great job for their